Good day, meteorologist DT here from WXRISK with our spring weather forecast doing March, April, May, and also look at June as well, and July and into the summer months here. So let's get right to it. Obviously, the grain situation is very fraught here with a lot of concerns. The geopolitical situation in Russia and the Ukraine is a problem, as well as the disastrous wheat crop, which the Chinese announced, I guess it was 2 weeks ago. So all sorts of weather issues. So this one is just the U.S. We're going to do the overseas markets a little later during the month here. So let's get right to it here. Also, I am suffering from allergies here a little bit, so I have to clear my throat. I hope it doesn't drive you crazy listening to it, but the allergies are what they are here in Virginia, where you are the pollen capital of America. All right, so this here is a textbook example of La Nina. And you can see that during January, February, and March, it's warmer than normal, slightly warmer than normal along the Gulf Coast, and then below normal, upper Midwest, Rockies, Pacific Northwest, and the rainfall, again, clear bias of above normal rainfall, Tennessee Valley, Ohio Valley, essentially east of the Mississippi River, up to the Appalachians. Then from Virginia down towards Texas, Louisiana is actually drier than normal. Now, the forecast, if you recall, back in December, we had the La Nina show the peak around January, which is what happened. But then look at all the lines here. You can see what it's doing. All the lines are showing that it's moving up in this direction here. So there was a strong consensus La Nina was going to weaken significantly during the second half of the winter, be over by April essentially, and then neutral conditions as we go into the late spring and summer. And the Australian model here in the bottom right, same sort of thing. Look at the green line. Peak of January, over by March, and then neutral by May. That's not what happened. Now we can see here, this is precipitation bias, December, January, February, this past winter. Notice the really very dry conditions, Western Corn Belt, into Nebraska, Kansas, lower plains. Meanwhile, the Eastern Corn Belt, where the green is, Ohio, Indiana, Southern Illinois, Kentucky, Tennessee, much wetter than normal. So, but the drought is a real problem. And we'll get into that in just a second, how bad it is. Temperatures for the winter, December, January, February, slightly warmer than normal in 2 degrees above normal, so in the Gulf Coast states, and then in the deep South, and then the temperatures really only much below normal, Minnesota, Wisconsin, North Dakota. Rainfall. Now, this is the typical La Nina. And if you compare La Nina winter this winter to the other 22 moderate La Ninas, you can see that it was a very close match. This is the rainfall on the right-hand side. I mean, this is what actually happened of the 22 moderate La Ninas since 1895. Notice that the Eastern Corn Belt was really quite wet. It was it's in some areas it was in the top 5 wettest. Meanwhile, the Western Corn Belt areas, not including northern Minnesota, but Iowa, northern Missouri, Nebraska, South Dakota, Kansas, some of them placed in the bottom, well, the 20th driest on record. Some areas the driest on record. It was a very dry winter for these areas. So this is what was different here was the dryness in the Western Corn Belt. That is not typical what you see in the La Nina. It's okay. Look at this is December. You can see that it was very warm. We all know how warm December was. Like I said, it was almost a continuation of November. And you can see the precipitation. Notice again the bias. Eastern Corn Belt really wet, anywhere from 150 to 300% above normal, while the Western Corn Belt anywhere from 5 to 50% of normal rainfall, and that extended all the way down the Plains states into Texas. Now, interestingly enough, if you look at the trend over the last 75 years, the Western Corn Belt and the Plains states during December, January, February has actually gotten warmer. So that's the trend over the last 75 years. But instead, what we've seen is, this dryness for the whole winter and in the Western Corn Belt. And we can see it again in January. Now, January was a cold month east of the Rockies. That was the coldest month of the winter by far. But look at the precipitation. Way below normal, the Western Corn Belt, except for a few pockets in Iowa and southern Minnesota. and down into Kansas, Nebraska, Texas. And then if we look at February, same sort of thing. Now, west of the Appalachian Mountains, February is fairly cold for most of the plains in the Midwest, anywhere from 3 to as much as 7, 8 degrees below normal. But look at the dryness. Again, western Corn Belt areas versus eastern Corn Belt. You can see that in all the months, December, January, February. Very clear bias here. The eastern Corn Belt getting a lot of precipitation, sometimes extending into Pennsylvania, New England. But the western Corn Belt, Iowa, Nebraska, South Dakota, Kansas, northern Missouri, extremely dry. And if we look at January, February since 1895 as a summary, you can see again western Corn Belt famine, dryness there. Eastern Corn Belt feast with the rainfall. Very, very clear delineation between the two areas of the Midwest, and extended into the plain states. Now this is an interesting graphic. Now this is the climate divisions. This is from December 31 all the way through March 6th. Okay, and all the different climate divisions of each state. So look carefully at the eastern Corn Belt. Let me see if I can call up my arrow here. There we go. And you can see when we move this, here you go. Look at the eastern Corn Belt. Look at all these climate divisions. Some of these in the top 20 wettest on record. See that? Kentucky, Ohio, Indiana. Very, very noticeable here. Meanwhile, the western Corn Belt, some areas, 110 out of 130. That's almost, some of the driest December, January intervals on record. And then Nebraska, almost driest ever. Northeast Nebraska, 128 out of 130. That's impressive. And of course, California, we know that California is the driest on record here. We know that. But the western Corn Belt, you can see how amazingly dry it was. Kansas, 119 out of 130, 114. Texas, 111. Meanwhile, eastern Corn Belt from Tennessee all the way down, unbelievably wet. So very distinct. And this is the last 30 days. This is February. Oops. Just look at February. Now in February, it's even more pronounced. Let me see if I call my arrow again here. Oops, didn't come up. Go. There we go. And then we can see in February, and here, we can see that the eastern Corn Belt, look how amazingly wet it was. Ohio, Indiana, Illinois, Southeast Missouri, the top 10 wettest Februarys on record. Meanwhile, most of Iowa in the top 10 driest on record. 123 out of 130, 125 out of 130, 125 in Nebraska, 130 in central Nebraska, driest February on record in Nebraska, 129 in south out of 130 in southeast Nebraska. So amazingly dry. Again, it's either getting it or you're not. That's really what it's coming down to here. So let me clip this with me. So that is, and we enlarge it. This is again February. You can just see this in more detail. I just enlarged this so you can see. This is the Midwest, the Corn Belt region. Look how amazingly wet the eastern Corn Belt has been for February, and look how dry Iowa, Nebraska, South Dakota, Kansas, southern Wisconsin has been. It's either feast or famine with the rainfall. Quite noticeable. All right, so it was essentially a classic moderate La Nina. The climate models showed a weakening La Nina in the second half that never faded. The climate models were wrong. They were weakening it too fast. The eastern Corn Belt is very different from the western Corn Belt, the plain states. And the dryness and the lack of snow in the plains and the Midwest was far more widespread and stronger than usual. So that was really quite pronounced with the lack of snowfall in the western Corn Belt. All right, let's get on to the dry conditions here. This is the drought map as of March 8th. You can see that the drought conditions are increasing here in the western Corn Belt. The eastern Corn Belt is saturated, as you can see. Virginia's dry, Georgia's a little dry, Louisiana's dry. Well, plain states, very, very dry conditions, except for the eastern Dakotas. If we look at Texas, we can see here in Texas, excuse me, that look at the dryness just in the last week here. D1 through D4, 75%, 74%. Last week, 67% up. I guess that would be 7 points in last week. D2 to D4, which is serious drought, 57%. Last week, 49% up, 8 points in the last week. D3 and D4, the dark red areas, just under 30% as of March 8th. Last week, 21%, almost up 9 points in the last week. Now, if we look at our trends here, our long-term trend, that's on the upper left, and the short-term trend, which is the last 6 weeks, we can see the dryness really showing up in the short term. But also, the eastern corn belt has been wet for several months now. You can see that in the long-term trends. So the dryness is very pronounced. It's a long-term trend. The deep south is turning dry as well. The eastern corn belt is the place to be in terms of the rainfall here, but the western corn belt is extremely dry, and as are most of the plains. And we can see this with the soil moisture. The last 30 days rainfall anomalies for the top 40 centimeters. Look at that. Unbelievable. So again, the eastern corn belt in great shape. Virginia is dry down to Georgia. That's always a troublesome sign because, when you get droughts during the summer months, they often start in the southern states and they expand towards the western corn belt. So far we're not seeing that because the eastern corn belt is super wet. But look at the dryness in the plains and the western corn belt. Now this is interesting. This is snow cover. So this is from September all the way through the end of February. And you can see the dark red areas in the heart of the western corn belt, Iowa, Nebraska, South Dakota, northeast Kansas, anywhere from 20 to 40% of normal snowfall. So the lack of snow cover on the ground in those areas is also a problem because there's nothing to melt, nothing to get into the soil. Now here's a sea surface temperature map. As of early March, you can see La Nina, very pronounced. You notice that it is getting stronger off in central equatorial Pacific, not off the coast of South America. Earlier in the winter, the La Nina was strongest off the coast of South America. Now, it's really strengthening here in central and western portions of the El Nino region along the equator. And we also have the PDO, the cold water from Alaska down to California. Typically, when you have a negative PDO, which is what this is, the cold water is a negative PDO. When you have that, you get a general dryness in the plains and the western corn belt, and you get above normal rainfall in the Pacific Northwest and the eastern corn belt and the Ohio Valley areas, which is exactly what we've seen. And also notice the dryness along the southeastern coast. Classic negative PDO. Just take a look at that map here, the bottom of the map, and let me go back to, I'll just show you what it looks like. You can see that there it is. It's negative PDO, dominating the pattern. If we look at the ENSO values here, we can see this is the regions, again, region 1.2 off the coast of South America. The critical region is 3.4. So if you look at the regions, you can see what's going on. The region off the coast of South America is now warming. And the coldest water has clearly shifted in region 3, 3.4, and it's actually getting colder again in ENSO region 4. So we are shifting away from an eastern-based La Nina to a central-based Central Pacific La Nina. And the subsurface temperature readings, you can see the cold water is increasing again along the equatorial Pacific, about 100 meters down, 75 meters down. This is, if you compare that image to a couple of weeks ago, there's actually no cold water left at all. So the cold water is increasing once again. Now, if we look at our latest forecast map projections, here's the CFS. So you can see that the CFS is clearly showing a trend of the La Nina continuing. So the dashed black line is the mean. The red lines and the blue lines and the brown lines, these are different model runs. So what they do is you take it as a mean, and then you see what the projection is. So if we look at our, call up our arrow here, you can see there it is, the black line showing the mean. Now this is as of March 4, and this one here was March 14th, and you can still see the same thing. All the way through the summer, it has La Nina. All the way through the summer into the hurricane season and the autumn season. So that's very dangerous. This has serious implications. La Nina has got real problems for rainfall in the Midwest if we have one, especially a moderate La Nina. Now the European model here came out. Now the black line here was the previous run in January. And then this one here was the February run, you can see that. And then the March run has just come out and it's showing the same sort of thing. You can clearly see that the model is leveling off the La Nina into May and then weakening it as we get into the summer. So we're now seeing the European model keeping La Nina around all the way through until mid or late May, then finally weakening it in June. So that's a delay. In other words, the European model here is shifting towards the CFS solution. That's what's important. Here's the Australian model. Same sort of thing. The green line now stays flat almost till May and then weakens it. So the La Nina finally falls apart by the time we get to June and July. So that's more La Nina into the spring months. That's a step towards the CFS solution, which is the one which is a real problem. Now, the IRI models, these are the climate models here. They're from February. They have not been updated yet. I do not know why. They should be, and they're not. So this is really old data. But you can see there's quite a spread here as well. Most of the models back in February were calling La Nina being over by April or May. So it'll be interesting to see in the future what, if any, changes these new climate models from the IRI Institute get around to showing. Now, here's the American models. We hear in the U.S. There are 6 of them. There's the Canadian model, which is the blue line, the CFS, which is the orange line. There's the GEM model, the GFDL, and NCAR, NASA. Now, the dashed black line there is the mean of all of them, but only the green line, which is the GFDL, weakens the La Nina by the time we get to May. All the other models are keeping La Nina going. You can see this until June. They all have it La Nina either weak or moderate all the way till June. This is a big change from what it was showing back in February. So this is a step towards the CFS solution, which is the extreme solution. So what we have here then is a negative PDO. All the climate models are showing La Nina, the U.S. climate models, holding until right to the spring until June. So that's a step towards the more extreme CFS solution. The climate models are showing a bias of weakening the La Nina far too rapidly. They've been doing this all winter long. And the CFS solution, moderate La Nina, well, it's just dangerous because the CFS solution, as we'll see for the summer, is giving off a strong signal for a major drought in the Midwest and the Plains states. So we'll get to that in just a minute. Now, this is from DTN. This is a nice graphic as well. What this is showing here is that during times of La Nina, when you have the precipitation pattern setting up in December through April, where you have a wet eastern corn belt and then a dry western corn belt plains and deep south, that June, July, and August, that pattern remains the same. It doesn't really change. The western corn belt turns dry, the eastern corn belt is close to normal. So this is indicating that potentially, especially if the negative PDO holds right through the summer, that what the current pattern, which is good for the eastern corn belt and bad for the western corn belt and the plain states, that's going to continue. Typically in La Nina, this is now for February, March, and April, and March, April, and May. So the February, March, and April in the upper left, March, April, and May in the lower right. Notice that the dryness here is quite pronounced during the first half of the spring in the western corn belt and the plain states and the deep south. Not so much March, April, and May, but definitely February, March, and April, first half of the spring. And then as we go to May, June, July, which is the beginning of the summer, and the second half of the summer, very clear signal of a dry bias in the plains and the western corn belt when you have La Nina. Now, not all the models are keeping La Nina going into July and August. Some of them do, not all of them. So it's kind of risky here. We don't know if that's going to continue. The temperature is not really a problem. There's not really a strong bias one way or the other with regard to April, May, or June, July, and August. In the plains and Midwest, maybe some tendency for a little below normal along the Gulf Coast. And if we look at the corn yield by impact here, we see what the problem is. Now, this is La Nina during the summer months. And for the growing season, on the left-hand side, that's the typical yield by climate division, from Ohio to Nebraska, from Minnesota to southern Missouri. But the image on the right-hand side shows you the deviation. So you end up getting a bias here of, 15, 20, 25, bushels per acre deviation in the western corn belt. So throughout all the Midwest, really, but definitely through the western corn belt. So let's take a look at our climate models. We have 4 of them to look at: the NMME, the IME, the CFS, and the European. So here we go. Now this here is the NMME, which consists of 6 climate models taken as a mean. So One in the upper left, let me show you bring up my arrow here so you can see. This one here is the NME. This is the mean. And then these, are the different climate models, the CFS, the Canadian, the GEM, the GFDL, NCAR, and NASA. So you take all these together, you put them into this is what you get. So if you can break it down some more, these are the different models. This is for April. The forecast for April, which this came out a couple of days ago, you can see that there is a strong bias for really below normal rainfall in the plains and the western corn belt, and some bias for above normal rainfall in the eastern corn belt. Well, that has been the trend as we've seen all winter. Now, how good is the NME? Well, let's take a look at it. This is June on the left-hand side. So from last year, notice the precipitation relative to normal. Here you go. So you can see it was quite dry in the upper plains and the upper Midwest, and then fairly wet along the deep south, and a little bit in the eastern corn belt. And the model forecasted, look at the dryness, and it had pretty good precipitation in the eastern corn belt and along the deep south, the Gulf Coast area. So this was a really good forecast. Now this was the forecast in March, and this was in March of last year, valid for June. This was June. This is what the forecast was. So they matched pretty good. These matched pretty good. Okay, that's good news. Now let's take a look at July. Now, the one image on the left, rainfall relative to normal for July of 2021. And then the image on the right was the March forecast for July 2021. And as you can see, it was way too dry in the eastern corn belt. That was not correct. It did okay in Minnesota and Montana and the Canadian prairies where they had a very dry summer, but it was way too dry in Missouri and the eastern corn belt. So that was not a good forecast. So the NME here has hits and it has misses. So I just want to point that out to you. It's not great, it's not perfect, but it is useful. All right, so here's the NME as a mean for April. And this is the March forecast valid for April this coming year, April 2022. Look at the dry biness here. Look at the extreme dryness deep south into Kansas, Texas, into the western portions of Iowa and Nebraska. Meanwhile, the eastern corn belt looks okay. The Great Lakes look okay. Now, this is for May in the upper left, and the bottom right is June. So let me call up my arrow here so you can see it. So this here is May, and you can see the dryness into the western corn belt a little bit, and spreading into the eastern corn belt, and then really dry in the central and lower plains. And then this here is June. And look how dry it is in the heart of the western corn belt. This is a drought. This is correct. This is drought developing. A widespread drought in the plains, western corn. Not so much the eastern corn belt, but mostly the western corn belt. If this is correct, this is what the model is showing. We don't know it's correct. Now here is the forecast for April, May, June as a 3-month interval. Notice that the eastern corn belt is pretty close to normal, while the western corn belt is on the edge, and the plains and the delta are really dry. So that's what that's showing. Now, if we look at July and August, again, this is the March data, you can see the model goes absolutely bonkers with the dryness. Look at this. Look how dry it is throughout all of the Midwest of the Plain States. This is a drought signal. This looks like 2012. That's what the model is showing. That's not what I'm showing. That's what the model is showing. Okay? Good. Make sure you understand that. And then this here is, there you can see, and July and August, same sort of thing. It's 2012. Now, why is it doing that? The model is doing this because it is showing, let me call it my map, this. All these models, except for one of them, keep La Nina in position all the way till June. So La Nina till June means dry conditions, means a problem, okay? So that's why the models are showing that. So that we looked at that. There we go. And then if we look at it as a mean, there's May, June, and July. It's just, that's scary. That's a dry looking map. Now, there are other models besides that one. This is the NMME. These are the international models, not the American models. This is the CFS. They have the CFS there, as you can see it. And then there's the European, the French model, the German, the British, and the Canadian models. Now, notice in all these lines here, let me call it up. Here's my arrow. You can see it. Only the CFS has La Nina going into May, June, and July. All the other models have it ending by May and June. See? They don't agree. This is a very different scenario. Now, look at here. Here's the French model, the European model. March, April, and May, they have some dryness in the Western Corn Belt, but it's not nearly as bad. And the European actually has it normal in the Western Corn Belt, March, April, and May, and both models have it wetter than normal in the Eastern Corn Belt. The Deep South is dry, the plains are dry, but again, nothing like the U.S. models. And here is the March, April, and May, and you can see this taken as a mean. You can see how wet it is Eastern Corn Belt. Notice that even Iowa is slightly above normal rainfall, either normal or slightly above normal. Missouri. So all the dryness is restricted to the Gulf Coast and the central and lower plains. Eastern Corn Belt, Western Corn Belt, much better shape. If this model is correct, it's March, April, and May look pretty good. So, the NMME climate models, what does it mean? Well, it means that all 6 of the U.S. climate models are really dry for June, July, and August. And they're showing drought. There's no doubt about that. Some of them will look like 2012. That's how bad it looks. It looks bad. The drought in the plains, the Western Corn Belt, builds as the summer approaches on these models. Now, the international models are much different. They have a much nicer March, April, and May than the U.S. climate models. Now, here we can compare some of the international models, and we can notice the trend. Now, this is the Canadian model. The one on the left is from February. The one on the right is from March. Notice that the red lines on left, which is all the different projections of the Canadian ensemble, show La Nina being gone by April. But the image on the right, notice there's a dip where it stays La Nina all the way till May or June. So it's trending towards the CFS solution a little bit. It's keeping La Nina alive. Again, delaying the demise of the La Nina. It's delaying the demise of the La Nina. This here is the German model. Notice what it's doing. It's keeping all the red lines, almost all of the red lines in the German model ensemble have La Nina right till July. This is very close to the CFS solution. And this here is the Japanese model, same sort of thing. Notice how that many of the members are keeping it below, neutral La Nina conditions through June and July. Again, it's a distinct shift towards the CFS solution. And this here is the British model, I believe. Yes. And you can see the British model, same sort of thing. Notice that the image on the left, the February, all the red lines take off like a jet, rapidly ending La Nina by May. Now, on the image on the right-hand side, you have a lot more red lines staying south of the neutral line, keeping weak La Nina going until June and July. Not all of them, but much more of them. It's a definite shift. If we look at the climate models themselves, this here is the European climate model. And for March, it had a huge polar vortex over Greenland, a broad trough running from the Pacific Northwest into Canada. And this produces a storm track where you end up getting a lot of rain in the Eastern Corn Belt. Western Corn Belt does okay, but it's pretty dry over the southwestern states. And this here is the April European climate model. Again, same sort of thing, but the dryness spreads. The trough shifts to the Pacific Northwest. You get a ridge over the southwest states and the lower plains, and you get dryness beginning to spread into the Western Corn Belt in April, and less rain in May. Now, here the climate model, the European climate model, develops a trough from Western Canada into the Western Corn Belt, and that produces a really wet May for everybody in the Midwest. So this would be very good to see if this were to happen. So, and then finally, this here is June. June, we see more of the same sort of thing. Eastern Corn Belt's okay. Western Corn Belt begins to turn pretty dry, as does the Upper Plains and southern Canada. And then if we look at the European climate model for this would be May, June, July, a 3-month period in the upper left, and then June, July, and August, you can see the dryness creeping back into the Western Corn Belt and the Plain states. Eastern Corn Belt looks okay. That's on the European. But again, the European does not have La Nina continuing through June, July, and August. So that's why it's different solution. Now here's the CFS. Hold on to your hats, boys and girls. This is April. Now the CFS is bonkers with the rainfall in all the Midwest and the Canadian prairies. The reason for this is because it has a positive anomaly, what we call a Greenland block in northern Canada and in Greenland, and you have a big trough over New England. So you're getting a lot of storms, and the active storm track really brings big rains in April into all of the Midwest. Now, the southern states are very, very dry, as is Texas, Arizona, Oklahoma. But the heart of the Midwest, the upper plains, and Canadian prairies look ideal. Now, the CFS in May, same sort of thing. Still pretty wet in the Midwest, more dryness creeping up towards Nebraska, and still very dry in lower plains. And then we go into June, you can see in June here, again, notice the dryness now creeping into Iowa. The really wet conditions are breaking down in the eastern Corn Belt. Still looks pretty good in Canada, Montana, North Dakota, but we can clearly see there's a ridge forming, and we now get a positive anomaly in the Gulf of Alaska, whereas before, in April, we had a trough. You see the trough in Alaska? See that trough there? And we also had it there in May. But in June, we start getting this positive anomaly, and that changes the pattern. The block shifts to Greenland, so the storminess goes to the East Coast, and the plains in the Midwest begin to dry out. And then we get into the CFS model for, this is July and August, and this just goes bonkers. And look at the extreme dryness in July and August in the heart of the Midwest during the growing season. I mean, this is 2012 all over again, if this is correct. I'm not saying it is. I'm saying that's what the model is showing. So the CFS climate model, Western Corn Belt and Plains versus Eastern Corn Belt. Clear delineation. It is forecasting a drought during the heart of the summer in the Plains and the Western Corn Belt. The model assumes moderate La Nina into June, July, and August. And that's why it gives off such an extreme signal, like the summer of 2012. I'm not saying it's right. That's what the CFS model is showing. All right, summary. Here we go. The models are consistently ended La Nina way too soon. They just have. Lack of rain and snow in January, February across the plains and the western Corn Belt regions have placed these areas in increasing drought. Many of the climate divisions in the plains, the western Corn Belt, top 15 driest 60 days on record from January to the end of February out of the past 130 years. Some of them have been the driest ever. The negative PDO signal, which is, the cold water from Alaska to California, often restricts or inhibits rains in the plains and western Corn Belt regions. The CFS model is showing much above normal rains in April and May. And the non-US climate models, the European, the German, the British model, the Canadian, the French, they're showing the same thing. Above normal rains in April and May. That's not the issue. The CFS model keeps La Nina going through June and July into August. And that's why it has a big drought, an extreme signal here for a drought. Most of the other climate models, which are not the CFS, do not have a moderate La Nina lasting into June. But the new March models are showing weak La Nina continuing into June. In other words, they are delaying the demise of the La Nina and now keep it weak all the way till June. They weren't doing that in February. So they're kind of shifting towards the CFS, and that's what has me worried. So the lack of rain and snow in January, February across the plains, the western Corn Belt, have placed these areas, like I said, in increasing dryness. Okay, so we know that's going to continue. And then finally, in the other scenario here, in the wet spring in the Midwest, dryness in the plains, this is our scenario number one. This is a possibility. 30% chance of a wet spring in the Midwest, dry in the plains, and then a near normal summer in the Midwest. Some dryness in the plains, the western Corn Belt, but not a big deal. In other words, close to a typical spring and summer, and probably the best case for the U.S. in 2022. So that's a 30% chance of this happening. In other words, close to normal summer. Now another scenario, let's call this scenario number two. We have a wet spring in the Midwest, it's dry in the plains, and then near normal summer in the eastern Corn Belt, but we have real dryness issues in the western Corn Belt and the plains, which are in drought. The western Corn Belt ends up living week to week, looking for the next good rain. You end up getting moderate yield loss in some areas in the plains and the western Corn Belt. This is a typical good spring, bad summer type of situation. So you have a pretty good spring, then you have problems in the summer. 40% chance of this happening. There's some yield loss, it's not a disaster, but given what we need around the world, this is not adequate. This is, a normal summer is not what we need. We need a perfect summer. And it's perfect spring. And then scenario number three. We have a wet spring in the eastern Corn Belt. It's near normal in the western Corn Belt, and it's dry in the plain states. Then as we get into the summer, we end up having a widespread drought in all of the plains in the Midwest, with the worst portion of the drought in the western Corn Belt. In other words, like 2012. This is not good. We don't want to see this at all. The CFS keeps the moderate La Nina in place, and that turns out to be correct right through June, July, and August. The chances of this happening, 30%. So in other words, between scenario number 2, 40%, and scenario number 3, which is the disaster scenario, that's 30%. 70% chance, according to our calculations, that we are not going to have a great summer. We're going to have problems. The issue is how bad it's going to be. So there's only 30% chance of having a good summer with near normal yield in the Midwest and the Plains states, whether it's wheat or corn or soybeans, oats, what have you. So with 70% chance of problems, the issue is how bad the problem's going to be. That's how we see it right now. And there's a real possibility with these other climate models that the CFS might end up being correct after all. So we'll have to see. This is meteorologist DT from WXRISK. I will see you over on the Twitter page and over on the website.